Okay, so this week in Algebra 1, we're going to look at simplifying radicals. So this is also the same thing as rewriting radical expressions. So we went ahead and gave you this table, which gives you all of your perfect squares and the square roots of them. So what this is saying is, say we take the square root of 16, we would equal 4. If we take the square root of 64, we get 8. The square root of 121, we get 11. Okay, so let this table help you with finding your perfect squares that are going to go into simplifying your radicals. So what I mean by that, if we look at simplifying the square root of 63, what are two numbers that multiply to be 63, one of which is in this list of perfect squares? Okay, and that would be the square root of 9 and the square root of 7. Okay, and we know the square root of 9 is 3. We don't know the square root of 7, we get a decimal. So this is our simplified radical form, 3 square root of 7. Okay, if we look at B, we have the square root of 43. So square root of 43, the only number that goes into 43 is 1 and 43. Oops. Well, the square root of 1 is just 1, and the square root of 43 is what we started with. So the square root of 43 here is just our simplified expression. So sometimes you're not able to simplify any further than what it's giving you. So looking at C, the square root of 126, if you don't know two numbers that go into 126, look at this table. We know 126 falls in between 121 and 144, and you're going to work your way down your numbers until you find a number that goes in and gives you a perfect number other than a decimal. So 126 divided by 121, we get a decimal. 126 divided by 100, we get a decimal. And keep working down your list. If you do that, you'll get the square root of 9 and the square root of 14. Because 9 times 14 is 126. We can simplify this. The square root of 9 is 3, and then the square root of 14. We can't simplify, so that would be our solution. So what if we have a number in front? So here we have 3 square root of 27. This is the same thing as 3 times the square root of 27. So we're going to rewrite that 3 times. And then the square root of 27. So what are two numbers that multiply to be 27? And that would be the square root of 9 and the square root of 3. We said earlier the square root of 9 is 3. So we have 3 times 3 times the square root of 3. And 3 times 3 is 9. So our simplified expression is 9 square root of 3. Looking at D, we have negative 2 times the square root of 48. So our negative 2 is going to hang out front. And then we're looking for our 2 square roots for two numbers that multiply to be 48. The thing you have to be careful about is we always want to pick the largest number. So we know 48 can be divided by 4. But there's a larger perfect square, and that largest perfect square is 16 and 3. And the square root of 16 is 4. So we have negative 2 times 4, square root of 3. Negative 2 times 4 gives us negative 8, square root of 3. And looking at E, we have 5 times the square root of 9. Well, here we already know the square root of 9 is 3. And 5 times 3 is 15. Alright, so now we're going to look at simplifying radicals when we have variables involved. So the numbers are going to be the same as what we've been doing, but when we're looking at our variables, we're going to always pick the largest even number that is just less than our odd number. Okay, so if we look at this, we have the square root of 25 x cubed. We know the square root of 25, so we're going to leave that. Okay, so x cubed, 3 is odd, so the largest even number under 3 is 2. And then x to the first. So 2 plus 1 is 3, okay, which is how we're getting that. And if we simplify this, Square root of 25 is 5. And the square root of x squared is x. And we don't know the square root of the single x. Okay, so anytime we're looking at taking square roots, we're always figuring out how many pairs go into it in terms of our variables. So looking at b, we have 5 times the square root of 4x to the 17th. So the 5 is just going to hang out. We know the square root of 4. And then the square root of x to the 17th. 17 is odd. The largest even number under 17 is 16. And then we have 1 left over to give us the 17. So 5 times the square root of 4 is 2. And then times the square root of x to the 16th. 16 divided by 2. So x to the 8th. And 5 times 2 is 10. So 10 x to the 8th times the square root of x. All right, looking at c, we have 63 x to the 7th. So 63 can be broken up to the square root of 9 and the square root of 7. And then x to the 7th is going to be the square root of x to the 6th times the square root of x to the 1st. So the square root of 9 is 3. We don't know the square root of 7. Times the square root of x to the 6th is x cubed. Times the square root of x. So when we're multiplying these, we're going to combine our outsides. So we get 3x cubed. And then multiply our insides. So the square root of 7x. All right, looking at d, we have the square root of 126 x to the 4th. What's nice is we did this one up above. So the square root of 126 is the square root of 9 times the square root of 14. And square root of x to the 4th, it's even, so we can just leave it. So the square root of 9 is 3. We don't know the square root of 14. And the square root of x to the 4th is x squared. So if we rewrite this, we get 3x squared times the square root of 14. Okay, so now we're going to look at multiplying and then simplifying. So this is very similar to what we did here in C after we did our first step of simplifying. So here we're going to multiply first because these are each already simplified radicals. So we have 3 times the square root of 5x times 2 times the square root of 15x cubed. So we're going to multiply our outsides. So 3 times 2 is 6. And then we're going to multiply the insides. So 5x times 15x cubed is 75x to the 4th. So we have 6 times, so the square root of 75, excuse me, can be the square root of 25 times the square root of 3. And then we have the square root of x to the 4th. It's even, so we're going to leave it the way it is. So if we simplify, we have 6. The square root of 25 is 5. We don't know the square root of 3. And the square root of x to the 4th is x squared. 6 times 5 is 30. X squared times the square root of 3. Okay, moving down to d, we have 2 times the square root of 12x to the 9th times the square root of 18x to the 5th. So 2's on the outside. If we take 12 times 18, we get 216. And x to the 9th times x to the 5th is x to the 14th. So if we simplify this, we get 2. So looking for a perfect square in 216, we get the square root of 36 and the square root of 6. And then the square root of x to the 14th is even, so we're just going to leave it. So we can simplify. 2 times the square root of 36 is just 6, times the square root of 6, times the square root of x to the 14th gives us x to the 7th. 2 times 6 is 12. X to the 7th times the square root of 6. All right, looking at C, we have 1/2 times the square root of 21x cubed times 4 times 4 times the square root of 7x squared. 1/2 times 4 is 2. And then this 21 times 7 gives us 147. And then x cubed times x squared is x to the 5th. All right, so 147, we can break that apart to be the square root of 49 and the square root of 3. And then x to the 5th can be x to the 4th and x to the 1st. So we have 2 times the square root of 49 is 7, times the square root of 3. The square root of x to the 4th is x squared times the square root of x. So simplify or combine what's on the outside. 2 times 7 is 14, x squared times the square root of 3x. And then lastly, we have 3x times the square root of 3x to the 4th times the square root of 27x squared. So we get 3x. 3 times 27 is 81. And x to the 4th times x squared is x to the 6th. What's nice about this is we know the square root of 81, and x to the 6th is even. So we can simplify this to be 3x times the square root of 81 is 9, and the square root of x to the 6th is x cubed. 3 times 9 is 27, and x times x cubed is x to the 4th.